Hello dear students, hope all are staying safe at your homes. So we already started our module 6 for basic mechanical engineering. We already have a brief discussion on what are the type of manufacturing processes. So in this session we are starting about metal joining processes or commonly joining processes, where what are the general processes we are doing being done for joining two metal parts. That will be discussed in a bit more detail. So when coming to the metal joining process, actually you are having two type of metal joining process. One is temporary joints, and the second one is permanent joints. Here, as per your syllabus, we will be dealing mostly with permanent joining processes. So why you require the metal joining process, or why you require a joining process? Because you already have seen casting and all. Why can't you build a product as it is as a single piece? Why you prefer sub-assemblies instead for a whole product? It's like that. Suppose you are having an automobile. It is very difficult to manufacture it as a single component or single piece, and the transportation and everything will be very difficult if you are having a single component. And if any failure happens, then also if you need to replace or repair any particular part of your product, it will be very difficult. So there comes the application of metal joining. We prefer items to be manufactured as sub-assemblies or very small parts, and the parts will be, or sub-assemblies will be, standard parts, so that you can make your manufacturing more economical also, and your whole product and combined or your assembled product will be a cheaper one. So it's actually metal joining. It's a what we are using, a technique is used for assembling your sub-assemblies to a final product. It's actually a technique, a simple technique, can be defined by you are doing some uniting operation. So it's a technique of uniting two or more metal parts. Please keep in mind that you are doing with some metal parts. Okay, we are discussing with metal joining, so that you can get your sub-assembly or a final product. You can find a metal joining process being done at almost all the places where you are having or handling metal parts. You can see it in your bicycles, in your bikes, even in your computers, in your printed circuit boards. Everywhere you can see any type of metal joining process. Say for example, if in a bicycle you can see welded joints. In a printed circuit board you can see soldered wired printed board. So those are all examples for joining process. And another type of joining method, that is a temporary joining method, where you can use nut and bolt, that is fasteners, screws, you can use rivets. All of them are called as temporary joining process. We will be dealing more about your permanent metal joining process. So when coming to that, welding, brazing and soldering are the mostly used conventional methods in metal joining, permanent metal joining process. So we will be discussing more into these three processes, not into much deeper details. We will be covering the basic aspects of welding, soldering and brazing. Okay, so next we can just move to what actually welding is, what are the different type of welding processes, and how they actually differ from each other. So the most commonly used permanent metal joining method is welding process. So welding, why? Because it can withstand very high forces, or it can withstand high levels of stress without much failure. Suppose you need to have a high strength member, like the frame of a bicycle, or frame of an automobile, chassis of an automobile, or your chassis of a bike, chassis of a bike. So in those cases we prefer welding. Why? Because you need a better strength, and much forces are being applied on those type of structures. Whenever you are going for those type of structures, you will definitely go for welding, where welding can be done through the application of heat. Say the definition can be like it's a process of joining two similar or dissimilar metallic components. Can be with the application of heat or without the application. Normally you are melting the material, melting to some plastic region, and then you are doing the welding. You can apply pressure, or you can apply any filler metal for doing the welding process, and you can generate in welding process. Heat is being generated. You can have the chemical reactions like in thermite welding. You can use electric arcs, electrical resistance you can use to generate heat. Frictional heat you can use. Any form of sound and light energy also you can use to generate that heat. Major applications we already discussed, like, and you can see here like steel furniture, gates, door, washing machine, microwave oven, and your automobile parts. Everywhere you can see your application of welding. You can find the application wherever you are utilizing some metal products or items. Okay. Advantages are it actually produces permanent joint, because I already told you that we are discussing more on to permanent metal joining operations. So it produces permanent joint. Large number of metals can be weld, because most of the metals we are available is having high weldability. So, or we are developing welding techniques where you can join those metals with low weldability. So, example is aluminum. You can have new techniques for welding aluminum alloys and all. So then your welding operations can be automized, that is mechanized, or it can be automated. Mostly our car manufacturing industry and places like that, almost all the welding operations are automated, being done by robots, because they are reducing the manufacturing error or welding error by utilization of robotic hands and all. And the welding has high corrosion resistance. Major aspect is mostly the metal and metal will be fused together, so the metal properties or the basic property of your metal is being say preserved in welding. Okay, so your joint is actually a complete 100% efficient joint you will be getting through welding operation. Definitely it will be having many disadvantages, or like definitely it will be having many errors happening through welding, but in when compared with your fastening like nut and bolt, riveting, etc., welding will give you much strength. Major limitations are already we told that we are generating heat for fusing the metals, so it can distort your workpiece, or your material can be distorted. Edge preparation is very specific preparation is required for the specimen or the workpiece. It produces chemical and physical changes, and it may give off some harmful radiations. It can also cause corrosion for your material or your product. Welded joints generally tend to corrode faster. Say for example, you can just check your automobile parts. Suppose if you are having a bike, say bicycle, if you are having, please check through the joint areas where you are having, you can find the weld. Normally the rusting will start from that particular welded areas. So those are some of the limitations. Definitely you need to face that because you need to do much work to reduce the chances of corrosion. Now coming to welding in detail, two type of welding are there. One is called as plastic welding, and the second one is fusion welding. So in plastic welding, we are not actually melting your metal in a complete form, not making it as a full molten state. Here actually the metals are heated and we just bring it to a plastic foam where it is a slight thicky like plasma style format, and we will apply some external pressure or force. You are not using any filler material and all. So examples are like forge welding and resistance welding. We will be coming into that in detail. So here major advantages, you need not go for a high temperature, or you need not generate a much higher temperature, but you need to use a very high force or a very high external pressure to do the welding. Fusion welding is generally what we are generally seeing all around in our construction operations and all. So here actually no forces we are using, but your metals will be brought to a very high temperature, and the metal to be joined or the places to be joined are heated to its molten state, and then they are allowed to solidify. So some form of fusion is happening, metal to metal fusion is happening. You can use a filler material if required. Say it will be based on the type of metal you are doing, and it will be based on the type of welding process you are doing. So commonly what we are seeing across is an arc welding or an oxy-acetylene gas welding. So in those cases we are having fusion welding. So fusion and plastic. Fusion is the most common thing where we are not having any external force requirement. Plastic welding, we are not generating much heat, or we are not bringing the metal to the molten state. Instead of that, we are just bringing the metal or the workpiece to the plastic state by heating, and then it's forced together with external pressure. So coming to the classification of welding process based on say arc, gas, and other methods you are utilizing for generating heat, or the type of welding process. Generally you can classify like arc welding, gas welding, resistance, thermit or chemical, solid state, and the new methods in welding where you are utilizing electron beams and laser guns. And related for process utilizing welding is your gas cutting, arc cutting, then you are having phasing, and much more simpler things that you are utilizing around for electronic manufacturing is brazing and soldering. So arc welding, when you are coming across, you can have carbon arc, that is the most common one. Then you can have metal arc, metal inert gas, tungsten inert gas, which is the TIG welding, and metal inert gas is MIG welding, normally utilized for aluminum alloy welding. Then you can have much more better ones like plasma arc, submerged arc, electroslack welding. Gas welding can be have the combination of oxygen acetylene, that is oxyacetylene, air acetylene, and oxyhydrogen. Resistance welding, it's a type of plastic welding where you are having butt welding, spot welding, seam projection, and percussion welding. Thermit welding is a type of chemical welding normally utilized for aluminum alloy welding. Solid state welding is actually based on friction, ultrasonic diffusion, and explosive. All those are the major types of welding process you may come across in manufacturing process when you are learning in detail. We will be discussing more on to the type of or general working of arc and gas welding only. So arc welding means a metal a arc will be utilized for joining the workpieces. So the method of fusion welding, in which the metals are joined, is heated to a molten state by utilizing an electric arc. So arc is a column. It's generated between the two electrodes, between an anode and a cathode. It's actually the flow of electrons across an anode and a cathode. It's like a continuous flow of electrons. If you can obstruct it by making a small gap in between the two electrodes, that is anode and cathode, the electron flow will be continuous, forming a spark or an arc. So that is actually arc. Say something similar to your thunder or lightning thunderstorms. same thing will happen. It's actually the flow of electrons from your clouds to the earth. So similar to that, you are making a space between your anode and cathode part, and where some high voltage is being utilized to generate that arc, and the temperature of the arc will be around some 6000 degrees Celsius to 7000 degrees Celsius, where it can simply melt your metal, and the melting will be only for that area concerned, or the workspace. And using that molten metal, a pool of molten metal will be formed, and utilizing that molten metal, you can do the fusion process. Normally in arc welding processes, a filler material is added so that you can increase the volume and strength of the weld joint. You can use filler materials with much good properties, where it can be fused, where the new material can be introduced, alloy can be can improve the weld quality. Normally the movement of the electrode relative to the work is accomplished by either a human manual welding or by mechanical means, that is you are automating or utilizing a robot, a machine, or you can use any other means where the movement of electrode you can utilize. In a manual arc welding, the quality of the weld joint will definitely depend on the skill and experience of the welder, and hence your weld quality will be much better in the machine or in a robotic welding. You can see a simple image where an arc welding is being done for a steel pipe. You can see the generation of arc, and here it's a manual welding process where it all dependent on your worker, the skill of the worker for getting a perfect weld. So as discussed above, how an arc is formed, it's actually a flame, or it's actually a sparking which is caused due to the passage of electric current across a resistant air gap. You are making an air gap in between your anode and cathode, similar in your spark plug, so it can generate an arc. Okay, so normally the types of electrodes used in gas welding are non-consumable electrodes and consumable electrodes. Non-consumable electrodes are carbon, graphite, or tungsten, normally used in TIG welding and all. Consumable electrodes normally used for steel or iron welding operations. They are consumed during the welding operation, and your electrode can be coated or flux coated. Flux coating is being given for making a shielding across the weld area, so that no oxidation of the metal is being happen. So that is actually shielded metal arc welding. In a shielded metal arc welding, the protection of the weld pool, you can do the protection by providing a covering of slag formed over the surface of the metal. Inactive gases will be generated through the thermal decomposition of your flux or coating material on the electrode. That electrode and everything, the welding process itself will be having practical experience. You will get practical experience from our basic mechanical lab. So we can have a discussion over there also regarding this shielded metal arc welding, flux coating material, all those things. And this is a manual metal arc welding circuit, where you can see that on the left side there is the welding power source that can be AC or DC, and one connection or one maybe earth cable will be connected to the workpiece or the surface of the work table, and the main power source, the positive power, will be connected to your electrode holder part or the electrode, and you can see the arc being generated, and the workpiece can be brought to a molten state, and your workpieces can be fused together to form a single piece. So this is a basic configuration. Again, you can see the electrode, you can see the filler material, and your electrode can be moved say towards left. So you can see the solidified weld metal at the bottom right side, and molten weld metal towards the left side. Again, one more figure where you can see it's a coated electrode. The outer part is the covered flux coating, and at the middle part you are having the core wire, that will be the electrode, and that particular coating will actually make a shielding for the welded area. Your metal will be in the molten state, and that particular state, suppose if you are having steel welding or say simply iron welding, if your molten metal is exposed to air, you will be knowing that it can cause oxidation, where that oxidation process is actually rusting, initiating the rusting process. So in those cases you will be having a flux coated electrode. So that flux coating will provide a shielding to prevent the oxidation, so that you can avoid the chances of corrosion. Advantages and limitations of arc welding: it's a most efficient way of joining the metals, mostly preferred due to its low cost, lighter weight and utilization of material. Almost all commercial metals you can join using arc welding, and it have much design flexibility. Limitations: if manually applied, then you need to have high labor cost, high energy is required, disassembly will be very hard, and defects are very hard to detect. Coming to the gas welding, the welding process that it actually uses a fuel gas combined with oxygen to produce a flame. So instead of producing an arc, here actually you are directly having a flame. So it can have a gas weld. Simply your normal gas cutters you will be knowing. So in that that's gas welding. It's also another use of gas welding option. So it's another fusion welding process. So you will be utilizing a flame which can melt your workpiece, and you can fuse the joint part and join the metal. So you can have combinations of oxygen or air, because oxygen or air can be utilized as the oxygen source. Fuel gas can be acetylene, hydrogen, propane or butane. So if you are using acetylene, then that particular type of gas welding is oxyacetylene or air acetylene, or you can go for oxyhydrogen, or you can go for oxypropane or oxybutane gas welding. It depends on what type of material or what type of material you are using as workpiece. General temperature ranges maintained will be around 2600 to 3300 degrees Celsius. So in the previous case, that is the arc welding process, the temperature was around 6000 to 7000 degrees Celsius. Here it is only on the half range, and it is mostly utilized because you can use it anywhere. Major types are, as we discussed, oxyacetylene, air acetylene and oxyhydrogen welding. These are based on the type of fuel gas being utilized by the operator. This is a oxyacetylene gas welding operation, where you can see the flame torch is being given to the workpiece, and that area to be welded is being brought to the molten state. In oxyacetylene welding, your acetylene gas is mixed with oxygen in correct proportions in the welding torch and ignited. The flame resulting at the tip of the torch is sufficiently hot, around 3000 degrees Celsius, to melt and join the metal. So you can see a typical oxyacetylene welding operation, or AW. You are having a mixture of acetylene, that is C2H2, and plus oxygen on the welding torch, and at the tip of the welding torch you will be having the flame, similar to a gas stove. Say the flame will be similar to the gas stove, but having more temperature. And you can use filler rod materials, and flame will be utilized for melting that filler round material and also your base metal. Another figure showing the complete circuit of an oxyacetylene gas welding operation. You can see the flame towers or the blowpipe. Acetylene cylinder is the orange one, and oxygen cylinder is the black one. This is an oxyacetylene flame. You can see the blue flame in the core flame at the center. So based on the concentration of or the amount of oxygen being utilized, you can classify, or you will get 3 types of flames. It's actually oxidation flame, neutral flame, and a reduction flame. So if you are providing a rich mixture of oxygen for welding operation, you will definitely get an oxidation flame. It will be having a good temperature, but definitely that will cause corrosion or a chance of corrosion for your welding. So in those cases, you will be using reduction flames or neutral flames. Now we can have a brief discussion about resistance welding. Here the parts to be joined are heated to a plastic state. Here it's a plastic welding process. Over a limited area, you are utilizing the resistance, actually electrical resistance. You will be having electric current passing through the area to be welded, and you can improve the resistance of that area. And if you are increasing that resistance, generally your heat generated will be more. So as your heat generated is more, your metal surface will, or metal area, the joint area where you require the joining, the gap between the two workpiece material, that area will be heated up, and it can be brought to the plastic state, and pressure can be applied continuously till the weld cools down. Where this is a plastic welding process, and you require much high pressures for joining the weld. Generally used for joining only thin plates and structures, those type of thin structures, but the welding is very efficient, and much lesser weld defects are being seen in resistance welding types. These are the type of resistance welding based on the place where you are doing the welding: spot, seam, butt, and flash butt welding. This is spot welding, where you can see that at the center there is the two workpieces being kept one over the other, and the red one that you can see is the weld, and you are having AC power supply electrodes. In between the electrodes you are having the two workpieces, and through the AC power supply you are actually circulating electric current, and a high force is being given at the tongs, or you are actually pressurizing that welded area. Means you just simply utilizing that resistance at that contact surface to generate heat, so that you can bring that area to a plastic zone, and using that force that you are using utilizing to make, or utilizing to keep that metal plates together, you can increase and decrease that force. So utilizing that force, you can do the welding. Seam welding is actually if you need a line welding operation, then you will be doing the seam welding, where you can see that your electrode will be like a wheel, and your wheel can be moved from, say, here it is like a wheel, or your workpiece. Here the workpiece is moved from left to right. So you can see here the red thing is the welded metal sheet, and as your sheet metal is being pulled out, you can see that the two metals will be metal sheets will be welded together. So operation is similar to spot welding itself, but whenever you need a line contact between your metal surfaces or metal sheet, you can use a seam welding. It's actually a continuous spot weld process. Coming to the butt welding, here normally your workpiece will be cylindrical parts, and it can be joined end to end. Here again you can see you can have a metal, your job will be kept in a machine wise, and clamps will be provided. High forces will be holding force will be provided from both the ends, and again power, you can see the AC power supply, welded joint you can see, and the stationary clamp. Heavy current will be passed from one metal piece to the other, so that the resistance at that metal to metal contact surface can be utilized for making your workpiece into molten state. Next one is a flash butt welding. Here actually you are doing a flashing process. Here actually flashing means you are generating a small arc between the two metal parts to be joined. You are keeping a bit more distance between the two metal parts, and as your welding current is turned on, you can see the flashing between the two surfaces. Means an arcing will happen between the two metal parts, and definitely you will be using a much high force. You are not generating much high temperatures as in arc welding here, and you will be utilizing the force that you will be hitting. You can see the movable clamp and stationary clamp. One part will be coming and hitting to the another second part, so that the welding happens, or the fusion will happen in between the metal parts to be joined. Coming to the thermochemical welding operations, we normally utilize exothermic chemical reactions. Types are actually thermit welding, atomic hydrogen welding. So thermit welding means here you will be utilizing a mixture of powdered aluminum and iron oxide, and you are placing that inside a crucible. The mixture is then ignited, and the resultant products obtained are highly purified iron and aluminum oxide slag, which floats on the top of the crucible. So here actually you are not utilizing any arc, or you are not utilizing any type of electrical source for generating the heat. Instead of that, you are utilizing an exothermic chemical reaction, that is the powdered aluminum and iron oxide mixture ignition. So that actually makes purified iron and your aluminum oxide slag. Aluminum oxide will be the slag, and the purified iron can be utilized for welding operations. Say for example, this is the figure. You can see the igniter or the crucible at the top, and at the bottom place you can see the two metal parts to be welded, and you will be having from the crucible, you can see that molten metal will flows down, and it will fill the gap between your work pieces, so that your welding or joining of the two materials will happen. So these are the major welding operations that you need to have a brief idea about. Please learn about your gas welding and arc welding operations, and how it's being done, what are the major types, and the basic schematic for gas welding and arc welding operations. And coming to the plastic welding, that is you are having a resistance welding we discussed in a bit more detail, and also one chemical welding process here, that is the thermit welding process. So with these much details, I am just ending the part of welding. We can just move to the other two conventionally used metal joining process, that is soldering and brazing. So soldering, you can join two or more metal pieces utilizing soldering operation. Difference is here, we are not melting the components to be joined in welding. We are actually melting the components to be joined. Here you are not melting the components to be joined. Instead of that, you are utilizing a filler metal, that is called as a solder, is utilized for joining the material. You will be knowing that the solder is actually an alloy of tin and lead, so that that thing is being utilized for joining metal pieces. So you can join it with a metal with non-metal also, where you can see its application in printed circuit boards. You can see the temperature range, that is the filler metal, the melting temperature of the filler metal will be less than 450 degrees Celsius, and it's also lower than the melting point of the components to be joined. It can be done very simply. Very less skill is required for doing a soldering process. Normally a soldering is being done by a soldering iron, which is actually an electrical resistance heater, and you will be using a flux during the welding process, or soldering process. Again, similar to the application of flux in welding, here also it is being utilized for removing any traces of surface film or oxides, to prevent the corrosion of that particular soldered joint. You can see a simple figure over here. You can see the soldering iron, solder wire, that is the solder or your lead that you are utilizing. Then here it is being shown like you are having some copper board and all, that a masking is being given, and there you can utilize the you can see the joining process in the below figure also in a PCB, where you can connect the joint parts utilizing the solder. Coming to the brazing, it's actually more we actually generate more temperature than in soldering. So the filler material is different. It's actually called as a spelter. It's actually an alloy of copper and zinc. The filler metal is more than the melting temperature of filler material is hence more than 450 degrees Celsius. Why we are utilizing brazing is it will give you better joint than a solder. No direct melting of the metals being joined, similar to your soldering operation. Better joint will be there compared to soldering, and similar to soldering operations, the filler material, it will actually flows into the two closely adjacent surface of the workpieces by capillary action, and that will do the joining process. Torch brazing is the most versatile method. We are utilizing an oxyacetylene gas. This is a brazing operation. So here you can see that the flux flux normally utilized is borax, and the filler material is copper and zinc, alloy of copper and zinc, known as the spelter. Advantages and disadvantages of brazing, we already have a brief discussion. Any very thin metals can be joined, metals with different thickness can be joined easily. No distortion is being there because you are not making your parent metal or workpiece to be melted. Compared to welding, it will be having very brazed joints are very having less strength, and joint preparation will be more high. Soldering versus brazing, this is the differentiations or comparison chart. This is very important for your examination and all. Here you can see the temperature of the filler material, which is below 450 degree in soldering and above 450 in case of brazing, and the filler material utilized the solder in case of soldering and the spelter in case of brazing. Much stronger joints are produced in case of brazing, and it can resist more corrosion. You can obtain airtight joints in case of brazing, and brazing is suitable for even thicker dissimilar metals, but soldering is only done for thin similar metal sheets or metal wires. So brazing we can use dissimilar metals also. And to conclude the session, it's a comparison of welding, soldering and brazing. Definitely this comparison chart will give an overview about the differences between different processes, so it will be very easy for you to learn, have a read on this comparison chart. And you can see that about here things about cost involvement, heat treatment requirement. Heat treatment is actually done to relieve the stresses, thermal stresses being developed due to welding operation. So in welding you require heat treatment. In soldering and brazing you don't require any heat treatment because you are not melting your parent metal. Okay, so that's all about the metal joining processes that you need to learn in your basic mechanical engineering. So have a look through the materials being shared in your ERP. If you have any doubt you can ask in between. So thank you for listening to this lecture. Thank you.